Hello, everyone. Welcome to our second session of performance testing, Train with Thoughts. This session will be consisted of two parts. In the first part, we'll present you some ideas, and in the second part, we'll have a Q&A session. The first part will be recorded, and the second one will be an open session without recording, where we can discuss freely about our experience related to performance testing. It's 1 minute past 4, and I think we can start. So welcome again. Previous session, we discussed about our approach of performance testing and the figures that we have for our application before and after applying them, and where we in the areas where we improved our application. Today, we will talk about how you can approach your application from performance testing perspective, the recipe for building a strategy of performance testing, and also some tips and tricks for performance analysis. Okay, so most of the two most common architecture types for software applications today are a monolith, where you have a big application containing all the data, all the business, and also the UI. So it's a single application. And also we have the microservices, where everything is divided into multiple applications, communicating each other in a certain way. Between these two types of architectures, there are a lot of combinations and also other architecture type. But unfortunately, all architectures have weaknesses, and they have performance issues, especially when they are not implemented correctly. Okay, so we managed to reach we managed to finish developing our application, and we are ready to go live. And we see that we have a lot of pending animations. We have poor response. We have bad response time. We have poor user experience for our application. What do we do now? Well, we start to look at the metrics that we have. There are various tools providing useful metrics for every programming languages. Most of them are free, and they give you some information that you can really use, but also there are a series which are paid. And for the subscription you pay, you gain more data about your application, which sometimes is really needed. Okay, what kind of metrics have you used until now for performance testing? The most common used we found are CPU usage, our memory usage, handy HTTP connection measuring, and also the thread dumps. But now let's see about logging a bit. Logging is very useful when we want to see the traceability of our application. It is free. The most simplest form of logging is free because it's written by developers when they write the code, the functionality for your application, or it can also be paid, generated by various tools. In some situations, it's really useful, and you will see a little bit later for that. What is very important for logging? First, it's important to be consistent, because it's really useful to read the logging and to easily identify problems in your application. For example, a lot of people have different abbreviations for certain words, and if everyone writes logging in their way with abbreviations or not, there will be a chaos in the logging, and you will spend a lot of time trying to understand what really happened in your application. Then, for logging, it's very important to be descriptive. It's really useful to have clear logging, because you identify the issues faster when you have problems in your application, and also is very, very useful when you want to create dashboards for monitoring. Last but not least, it's very important to be relevant. It's not useful to log every instruction from your application, but it's very useful to identify the one that matters and the one that are really important for your business, for your context. Okay, we know the qualities of the logging, the attributes which we must have, but what should we log? First, for example, we can log the duration of a method. This is really important when you want to see which part of your application was slow, or how time it took. We can log also the user who executed the action. We can log a certain flow, when it was executed or not. For example, for microservices, we can log the unique identifier of a request in order to build the chain of applications, the chain of the modules touched by that request. For example, we can log database call, third-party calls, external calls. There are a lot of things that we can log and measure, but we really need to identify which is really important for us. Okay. I see that from the poll question, you really put some time on the CPU and memory usage, which is really good. They gave us a lot of useful information, and we will see next how we can use that. Okay, so before starting the performance testing, we have to prepare a bit for this. First, we have to analyze our application. We have to know what our application does, how it is constructed, what components there are, if we use a database or not, which type, if we interact with third parties. There are a lot of technical stuff that we need to know from our application, because it would be very, very difficult, and I guess irrelevant, to performance test an application that you don't know. Then we have to identify the user activity flows from our application in order to know which components are affected for each flow. Then for each flow identified earlier, we have to identify the atomic actions that it does, to know which is executed when, and to make sure that they are valid. Okay, now that we are ready, let's see the recipe for building the performance testing strategy. First, we start with each atomic action. We have to test it in order to make sure that each individual action is valid, is available, and also it manipulates correctly the data that we have. After this, we start to make the user activity flow. We have to test it, the whole chain. Basically, we make the change of the of an atomic actions. But like I mentioned, we have to make sure that it is valid, and Also, it manipulates the data correctly, because it doesn't make sense, for example, to test a flow which is not reachable from your application, or which actually doesn't make sense, which is not connected an action with another. Then, based on the logs from production or any development environment, we have to take the duration time between the user actions to elaborate a close to reality test. For example, we have the times and conditions section when you install a new app, and there is a scroll there that you have to move down in order to agree and to go to the next step of the installation. There are different possibilities there. You need at least 1 second to scroll down if you don't really want to need, but you can also spend like 10 minutes there because you need to read it carefully. So each value between this interval is relevant for performance testing. Last but not least, we have to adjust the parameters for our performance test, because because different parameters means different performance testing type. So basically, changing the number of users we execute the performance tests with, or the test duration, will give us a different performance testing type. Okay, now that we see which is the recipe for the performance testing strategy, let's see how we can apply it for our applications.
Hi there. Like Katalin mentioned, once we find ourselves into the position of benchmarking the application we're developing, we must find a way to understand the app in connection with the performance goals we set. We all want our application to be very popular and be used by a lot of people, but we have to make sure that aspects such as user experience or performance are taken care of. Since Katalin mentioned about a demo, for today, let's take for an example, an application for employee management, which, for example, might serve departments in a company such as HR or financial. This app has modules such as for new hires or promotions, people management, for other such functionalities. As a small demo for this session, we want to present the way we would design and interpret a performance benchmarking strategy for such an application, and forms to read the results. As an extension for the previous session we had in March, we actually, this is the way we actually created our performance tests based on the improvements that made us achieve the performance goals that we and our client had in our real life example. For today, we prepared a basic REST API application that exposes methods that could serve functionalities such as the ones for an application for employee management. In parallel, we developed a separate project that manages the performance testing strategy, and this is a Gradle project that contains the tests included into the benchmarking, and they use Scala as a programming language and Gatling as a performance testing tool, a performance testing framework. It is, and we chose these technologies because these are actually the ones that we used for one of our clients. And back then, we preferred Gatling because it had a very easy and highly descriptive way of writing load tests, and that generated some really nice reports, and very easy to understand for both technical and business members of the team. Also, it's free, it's open source, and it has a pretty big community behind it that we were able to find examples in and answers to the issues we might have had back then. Itself, the performance testing project has the goal of mimicking the calls that a true user's interface might do to its server in a more intense way, let's say, in order to achieve the performance testing goal. This being said, we have the employee department management application that exposes the API. And as presented earlier by Catalin, our tested and successful recipe is the one that involved the 3 steps he mentioned. We analyzed the application, we chose separate logical flows, and for each one of them, we separated into a smaller, more atomic steps in the chains of action. Once we've broken down the application we wanted to analyze, we can now rely on them into building the performance testing strategy backup. So if we were to use our example, we should start by analyzing the app and then choose a flow to benchmark. Let's say, for example, the functionality of creating the new department in a company. And after that, that adds the new employees to it. To separate this flow into to follow the recipe, let's say, and separate it into smaller actions, we would probably result in something like, at first we check that in the list of available departments, we don't have the one that we want to add. Then let's imagine we don't see it and we try to create it. And after that, for this new department, we start adding the new employees to it. The fact that we were able to identify the steps sets basically the base for the performance tests we should write. Now let's get to the nitty-gritty. Let's see the project that I promised you to show. This is the project for the performance testing approach, which basically sets as support for the testing of the performance with the code that we wrote. Here you can see, for example, we set specific folders in which we have tests for each functionality we identified. And let's take our example. Here you can see 5 files. And I can, if we remember the recipe we just discussed, at first we create separate tests for each action in the flow. This is one example for the one which adds an employee to an already created department. And if we take a look at it, we can see that in the first section, we set the necessary parts of the request, which in our case is a post request to a certain path in the application, which is found in our case because it's a demo app in our local environment. And we have then all the necessary parts for it. We then set a scenario, which basically says however the sequence of steps should be followed, and where to get the data from. In our case, we have them in CVS. This is just an example. Another really interesting part, it's the last section in which we set the strategy under which we run the scenario. And for them, we can actually do, we can set the amount of calls per second and during how many minutes or seconds. We can set even auxiliary aspects such as pauses or even spikes in the request. The second step, it would be to chain the smaller action, like for example, getting the available departments, then storing a new department and adding employees to it. We can actually chain them together in a separate test that will takes between 1 Okay, sorry about that. Uh, we can check the available departments and see if the department that we want to add is there. It might take between 10 and 50 seconds, 5 seconds, and then we can add it. But if the storing has failed, I don't want to further go up with the storing of employees. And here I can see that I tried to mimic the way a true user would action. He would stop if the storing of the department would fail. Okay, then another aspect we've touched so far is the performance strategy approach that we can apply. And here I'm talking about either load testing the app or stress testing, spike testing, or let's say endurance, volume testing the app. And each one of them showcases different measurements about our application that we might take into consideration if we want to go live. This can also be simulated by applying the right setup for running your scenario. And for example, in my definition of an endurance testing, I thought for my app, I will start I tried to mimic the way an application would be used in a real life environment. Basically, let's say at first nothing happens, then the people get to work at once. They will log into the application. And after that, until the end of the day, they will start doing stuff like different calls and see however that situation might go. Okay, for the final part of the demo, I can show you some results contained in a really easy to follow report generated by Gatling based on the runs that I've done in this scenario. This is a report generated by Gatling for the load test I run. As you can see here, I have the call, which basically makes the 3 steps and loops them 1,500 times. Here we can see some really interesting information about the response times, which are further detailed in this lower section. And if we check, again, we can see the specific form of a load test and other such measurements based on which we can start our improvement process. We can go into details, and if we check it step by step, we can see that the most time-consuming action is the one that adds an employee to a department. Alongside this, we can also check the architecture and see the logging, because this is another most important fact. The fact that, for example, in our case, the application is a layered app and has service A called service B and service B called service C. And we can already, by checking the logging, tell which is the service and the method that triggers the most time latencies and pinpoint the way we should start our performance improvement strategy. Okay, now that we know what to improve and what to start addressing, we can further see what is the thing that helps us the most when checking the logging. Now we know how to connect with the result of the performance test, and we can start thinking about improvements based on the response times, the breaking points we see, or the resources showcased by the reports. We can now pinpoint the starting point of our performance improvements. Logging can be a very useful tool, especially if we find a way that saves time in order to interpret the logs. And currently in the market, we can see a lot of really useful solutions which automatically, in a query-like manner, extract data about certain events or details about those events. which we can use in understanding better our application. And just like Luigi wouldn't be without Mario, the same way logging wouldn't be the same without monitoring. And for this subject, we invite Joona to present the way they achieve this process at Maestro.
Hello. Hi all. My name is Joona. I'm from Maestro, Finland. I'm a CTO at Maestro, and I've been working with these bits and ones and zeros for some 20 years and more. So what I'm going to tell you about is our story at Maestro about how we monitor our application in the live environment. So Katalina and Irina showed how it should ideally be done, and I really like what they are doing. And performance is something that I really care about, and it's nice to see different approaches on that. So to make this interesting, I have a real live application, our ERP system at Maestro that we're building. I want to give you a little bit of a background for it, so it's easier for you to understand what I'm talking about. So this is a multi-tenant SaaS application. It has all kinds of business transactions. There are reporting and there are APIs to support e-commerce and so on. Currently, we have some 5,000 active users every month. Its kind of usage pattern is so that people start using it in the morning, they use it throughout the business hours, and it's constantly quite heavy load throughout the business hours. At peak times, we have some 400 requests per second. So that's kind of the idea about the load. And this is an application that has a long life cycle. It's been 10 years in development. There is roughly 1 million lines of code. It's modern web UI with .NET backend and SQL Server database. So there is certainly some complexity in it. And in complex applications that cover a lot of functionality, it's sometimes quite difficult to understand what's really going on there. So that's the key point of my presentation here, is that I'm going to show you how to figure out what is the most important area, what provides you most value when you are working with an existing application and want to improve its performance. Because you only have a limited amount of time to do development on performance issues. So it makes sense to find the area that gives you best investment of your time. And a key tool for you, introducing you to the idea of telemetry, like logging. It's data points about the usage, performance, and failures of your software. So it's a little bit of a broader concept compared to logging. It's something you have to instrument in your application for it to send this data. You need to add some custom code to do that, or you can use an SDK such as Azure Application Insights, which is what we're using at Maestro, or there are other tools like OpenTelemetry. So basically, the idea is that when user clicks a button or does an action in the application, the telemetry item you get from that is who the user was, what they did, and some details to help you segment that. So you don't need to exactly identify who the user is. There might be some privacy concerns with that, but it's useful to know who was the customer and perhaps what role the user was in. And what action was performed is something that your developers should be able to connect to the code so that they understand that what area in your code base that relates to. And the segmentation, the details could include operating system, whether it was mobile or desktop, duration, success, failure, all kinds of details like that. So with that, you get a lot of data, and it helps you analyze things, analyze your usage, helps you understand the usage patterns that go on in your application under the hood. And our application, it does not run on Azure. It runs in our own data center, but we're using these Azure application insights just to collect telemetry. So you don't need to be using Azure, you don't need to use .NET, because that tool works with PHP, JavaScript, C++, and even Java, and so it's a cross-platform tool. Right, so telemetry enables us to do observability, which is something that allows us to make hypotheses, assumptions on what might be going on, and then we can ask questions, analyze the data, and see whether our understanding was right. So our application is instrumented to send this telemetry data. So every action, every page view sends some data. In addition to that, we collect exception data, performance counters, and so on. And we collect a lot of data, so 100 million data points per month. So that gives us a lot of opportunities to analyze what's going on. We do have predefined alerts. So if there are a high number of exceptions, we get an alert. If the average response time is high, then we get an alert. So these are kind of basic monitoring things you might do. But in addition to that, we use the data to support our decision making. Which bug should we fix? Which is the highest priority bug? Which is the highest priority performance issue? So next up, I'm going to demonstrate you a little bit about actually in the real life environment, what's going on. Just hang on a second. And now we're going live into our application and see the telemetry we get. Okay. This is the Azure portal, and I have written a simple query that shows us the raw telemetry data that comes from our application. This is 15 minutes old data, so it's fresh, live, real application. Telemetry data, we collect the time when it happened, what was the duration for the request, what request was it about, some segmentation data, who was the customer, and so on, whether it was done on a PC, mobile device, or whatever. But we get a lot of these 100 million items per month. As itself, it's not really useful. So let's move one step further and look at the slowest requests, which is another way of looking at things. So this is basically the same thing. It's the raw telemetry data. This is from everything that happened within the last hour. And I'm interested in which requests were taking the longest time to execute. So here I can see that, wow, that was something bad. There is 91 seconds to execute one request. It's unacceptable. I don't know what's wrong there, but it's clearly not optimized. I can also see that there are many received API calls that are taking quite a long time. Search, I can understand that it's kind of a heavy piece of functionality. it goes through a lot of data, but still 30 seconds, it's not very nice. So based on this, you might think that these are the items where you should focus your work. But let's remember, this is only 1 hour. 1 hour and some individual requests are here. It could be that there was some, I don't know, network problem that was monitored kind of momentarily causing some problems or something else. I think we should look broader. So now let's take the power of aggregation here. So I'm looking at the average duration. This is better than individual events. So on average, I can see that the sales entry event has been taking 11 seconds on average. Some report API is 4 seconds. So the numbers are on the not so bad as the 90-second example previously. But on average, if something takes 10 seconds, it's not really that good. So and this is the duration or the time window we're looking at. It's for 1 day. Let's take even one step further. And now I'm also including count, so how many times the specific functionality was executed. And then multiply number of executions by the average execution time to get the total execution time in seconds. So this gives a better idea because it's more important usually to fix something that is used really often, something that users are executing all the time. If that is slow, then kind of the overall feeling of the application is that it's slow. If something that is not used so often, it's slow, users may be accepting that. So let's look at this. I can see that the purchase invoices API, it's executed 60,000 times per day. It's in the half a second ballpark. But I can see that of the total execution time, it's relatively heavy compared to any other piece of functionality. I can see that there is some invoice statement functionality that on average is close to 1.5 seconds, but it's not executed that often. So let's now turn this into graphic. It's the same data. And now I have a bar chart here, so I can see that, yeah, really this purchase invoices API, it's very heavy compared to any of the other bad items. So it's a very potential candidate to work some optimization there. But let's take even a deeper look here. So it's the same thing. I'm looking at the telemetry. I'm trying to find the slower requests. I'm looking at the average duration, how many times it's executed, but now also how many users are impacted. So of the top 3, I can see that roughly 1,600 users are impacted or are using these features. So this is one more metric you could use to determine where to focus, what to fix. So looking here, what metrics you use, it's entirely up to you and depends on your situation. But I would think that something that is being used a lot, has a high number of users, and has a bad performance characteristics on average duration, then that is something where I would focus my development efforts instead of something that is rarely used and it's not used by many users. So with application insights, analytics capabilities, it's entirely up to you what kind of a query you might build here. And you might go and segment it even further to see that who is the customer who's using the most resourcing time. Are they doing something different? Are they using the application in a different way compared to everyone else? Which might give you some ideas on and looking at their usage pattern in more detail to understand what's going on. But that's the power of telemetry and the analytics tools, whatever you use. You don't have to guess, you don't have to ask anyone, you can see the data. You probably want to confirm it with interviewing some potential customers, some users, but you already have an idea, you already have a hypothesis and some data to back you up in those discussions. So I'm going to show you one more thing. This is quite exciting. We're doing an analysis every time we do a deployment to production, which is something we last did some 2 weeks ago. We are interested in what kind of a performance impact our releases have, because performance is critical, and when we change the production environment somehow, we want to see what effect, what impact it had, so that we can learn from it. So I'm doing a little bit of explaining what you see here. This is comparing the time window of 2 weeks before the update to 2 weeks after the update. So before and after. Let's take, for example, the first row here. It's some piece of functionality called modify supplier. It's something that is executed roughly 500,000 times during this time window. Its average duration before deployment was a bit more than 100 milliseconds. And after the deployment, it's lower, it's now 200 milliseconds and a bit more on average. And the performance delta, it's changed for the worse, something happened. And we can see that the relative impact, so how many times it was executed, what was the added execution time on average, it has accumulated to, well, that's a lot of time, hours of execution time spent on that feature. So based on this, there are other features that have some change. Other two here, they have some improvement. Something is a little bit slower, but you get the idea, I hope. So that this tool allows us to find that functionality that was impacted the most by our deployment. And we have 2 weeks of data on either side, so it's in total some 100 million data points. It covers all the functionality we have, all the users we have, and I think it would be very difficult to find this out manually or by listening to customer feedback, because it's not always so balanced in this sense. And it's quite a complex query. It took some time to tweak this, but yeah, it's useful. We do this every time we do a deployment. I usually do it when we do a deployment. I look at the data first thing in the morning to see any early signs of performance problems, and then a couple of days later, so that we have a longer time window to analyze. So yeah, that's an interesting thing, and I would love to chat about this in the Q&A section. There are all kinds of other things that this tool enables besides performance analysis. You can also have a same kind of look on your exceptions. So you can use the same tactics to understand if you have any new exceptions, new bugs introduced by your latest deployment. Or if you're analyzing for a longer time window, you can see that what is the exception that is causing you the most problems for your users. Or for product management perspective, it might be interesting to understand which features are used the most often, and do you have maybe some features that are not used at all, which may give you an opportunity to simplify your code base. So yeah, that's pretty much it for what I wanted to present to you. Hope it was useful. That was it for the presentations. We are now ready to take a little break, a couple of minutes to maybe have a drink or quick bathroom break. So if you have questions, please be back. We are having a Q&A session for everyone who wants to join that. For that, we will make everyone a panelist, and that part will not be recorded, so feel free to discuss freely, and we can discuss on performance and have an exchange of minds on this topic. Really looking forward to that, so please be back in a couple of minutes. Thank you.